Hello students, welcome to the Department of Collegiate and Technical Education. ಇವತ್ತಿನ ದಿನ ನಾವು ಬೇಸಿಕ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಪವರ್ ಸಿಸ್ಟಮ್ ಅನ್ನೋ ಸಬ್ಜೆಕ್ಟ್ನಲ್ಲಿ 6th ಯೂನಿಟ್ ದಟ್ ಈಸ್ ಬೇಸಿಕ್ಸ್ ಆಫ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಅಂಡ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ನ ಸೆಷನ್ 38 ಇದ್ರ ಬಗ್ಗೆ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಲೆಟ್ಸ್ ಸಿ ಸೆಷನ್ 38ನಲ್ಲಿ ನಾವು ಏನೇನು ಟಾಪಿಕ್ಸನ್ನು ಕವರ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂತ. ಸೊ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕವರ್ the topics AC transmission and distribution system with single line diagram and the various components of electric supply transmission and distribution systems. So these are the two topics that we are going to cover in this session. So now what is transmission of electric power? In your earlier units you have studied about the various generating stations, the various sources of electrical energy. So as we all know, energy can neither be created nor destroyed. So energy is already present in various forms, and the energy in these forms, various forms, we can convert it to electrical energy. And the place or the point where electrical energy is generated is called generating stations or power plants. So you also know the various sources of electrical energy, like we have heat energy, we have wind energy, water energy. So the energy available in these forms can be converted to electrical energy and finally can be utilized, because electrical energy is most advantageous form of energy when compared to other forms. So ultimately electrical energy is being generated, transmitted, distributed, and finally it is consumed or utilized. So this entire network from the generating stations to the consumer point is called electric supply system. So athwa ನಾವು ಏನು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿನ ಜನರೇಟಿಂಗ್ ಸ್ಟೇಷನ್ನಲ್ಲಿ ಜನರೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಜನರೇಟ್ ಮಾಡಿದ್ಮೇಲೆ ನಾವು ಏನು ಮಾಡಬೇಕು, ಅದನ್ನು ವಿ ಹ್ಯಾವ್ ಟು ಯೂಸ್ ಇಟ್. ಸೊ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂದರೆ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿನ ನಮ್ಮ ಜಾಗದ ತನಕ ಅಥವಾ ಕನ್ಸ್ಯೂಮರ್ ಲೊಕ್ಯಾಲಿಟೀಸ್, ಕನ್ಸ್ಯೂಮರ್ಸ್ ಅಂದರೆ ಯಾರು, ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿನ ಉಪಯೋಗಿಸ್ತಾ ಇರೋರು ಕನ್ಸ್ಯೂಮರ್ಸ್, ಲೈಕ್ ವಿ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ಸ್, ಡೊಮೆಸ್ಟಿಕ್ ಪರ್ಪಸ್. ಸೊ ಅವರನ್ನ ನಾವು ಡೊಮೆಸ್ಟಿಕ್ ಕನ್ಸ್ಯೂಮರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಇಂಡಸ್ಟ್ರೀಸ್, ದೊಡ್ಡ ದೊಡ್ಡ ಇಂಡಸ್ಟ್ರೀಸ್, ಫ್ಯಾಕ್ಟ್ರೀಸ್, ಅವ್ರನ್ನ ನಾವು ಇಂಡಸ್ಟ್ರಿಯಲ್ ಕನ್ಸ್ಯೂಮರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅಟ್ ದ ಸೇಮ್ ಟೈಮ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಈಸ್ ವೆರಿ ಮಚ್ ರಿಕ್ವೈರ್ಡ್ ಇರಿಗೇಷನ್ ಪರ್ಪಸ್ ಅಲ್ಲಿ ಇರ್ಬೋದು, ಎಜುಕೇಶನಲ್ ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್ಸ್ ಇರ್ಬೋದು, ಹಾಸ್ಪಿಟಲ್ಸ್ ಇರ್ಬೋದು, ಟು ರನ್ ವೇರಿಯಸ್ ಎಕ್ವಿಪ್ಮೆಂಟ್ಸ್, ಮೆಷಿನ್ಸ್, ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಇಸ್ ವೆರಿ ಮಚ್ ನೀಡೆಡ್. ಸೊ ಈ ಕನ್ಸ್ಯೂಮರ್ ಲೊಕ್ಯಾಲಿಟಿ ತನಕ ಜನರೇಟಿಂಗ್ ಸ್ಟೇಷನ್ ಇಂದ ಪವರ್ ಅನ್ನ ನಾವೇನ್ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತೀವಿ ಅಥವಾ ಟ್ರಾನ್ಸ್ಮಿಟ್ ಮಾಡ್ತೀವಿ, ದಿಸ್ ಎಂಟೈರ್ ನೆಟ್ವರ್ಕ್ ಇಸ್ ಕಾಲ್ಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಸಪ್ಲೈ ಸಿಸ್ಟಮ್. ಸೊ ದ ಕನ್ವೇಯನ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಫ್ರಮ್ ದಿ ಜನರೇಟಿಂಗ್ ಸ್ಟೇಷನ್ to the consumer premises or consumer locality is called electric supply system. An electric supply system, mainly it consists of three components. First, the very first one is the generating station or the power station where electricity is being generated, and this electrical energy is transmitted over a very long distance. So you have the transmission lines, and finally it is distributed among all the consumers. So that forms the distribution system. In between this generating station and the consumer locality, we have a very complex and a huge network of conductors. So this huge network of conductor, it is called transmission lines. So three main components of electric power supply system is the power station, the transmission lines, and the distribution system. Now let us consider the generating or the power station. So you have already studied about the various power stations where we can generate electricity or electrical energy. So the generating station, it is nothing but a place or a point where electric power is produced. So how it is produced? With the help of three-phase alternators or three-phase generators which are running parallelly in order to generate electricity. The usual generation voltage is 11 kV. But apart from 11 kV, there are certain other voltage levels also at which electricity can be generated. We will look into that later on. The various generating voltages that are available, we can see it later. So as of now, generating station is a place where electricity is produced with the help of three-phase alternators or generators which are operating in parallel. The usual generation voltage is being 11 kV. Next, the transmission system. So the generated power, it has to be transmitted to the consumer locality, as I said earlier. And this transmission can be either overhead system or underground system. Overhead system ante helidre, ನೀವು overhead system ನೀವು ದಾರಿಲೆಲ್ಲ ನೋಡೇ ಇರ್ತೀರಾ. So it is through overhead conductors. ಈ ಕಂಡಕ್ಟರ್ಸ್ ಅನ್ನ ನಾವು ಟವರ್ ಮೇಲೆ ಪ್ಲೇಸ್ ಮಾಡಿರ್ತೀವಿ. So it can be either overhead system or the underground system. But the most widely used system is the overhead system because the cost of underground system is very high when compared to overhead system. But where very thickly populated area or congested area where laying of overhead transmission lines is almost impossible, definitely we can go with underground system. So underground system na ನಾವು ಬರೀ shorter distance ಗೋಸ್ಕರ ಮಾತ್ರ ಉಪಯೋಗಿಸ್ತೀವಿ. Overhead system it is for longer distance. ಅದರಲ್ಲೂ ಕೂಡ ಅಂಡರ್ಗ್ರೌಂಡ್ ಸಿಸ್ಟಮ್ ನ ನಾವು ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಸ್ಟೇಜ್ ನಲ್ಲಿ ಉಪಯೋಗಿಸ್ತೀವಿ. ಮತ್ತೆ ಥಿಕ್ಲಿ ಪಾಪ್ಯುಲೇಟೆಡ್ ಏರಿಯಾಸ್ ಅಲ್ಲಿ, ಕಂಜೆಸ್ಟೆಡ್ ಏರಿಯಾಸ್ ನಲ್ಲಿ ಎಲ್ಲಿ ನಾವು ಓವರ್ ಹೆಡ್ ಲೈನ್ಸ್ ಅನ್ನ ಹಾಕೋದಕ್ಕೆ ತುಂಬಾ ಡಿಫಿಕಲ್ಟಿ ಇದೆ, ಡೇಂಜರಸ್ ಇದೆ ಅಂತ ಸಂದರ್ಭದಲ್ಲಿ we can go with underground system. So the power transmission can take place with the help of either overhead system or underground system. So let me talk about the transmission system. So from the generating station, the electricity, it has to be transmitted over a long distance to the consumer localities or the load center with the help of conductors. Obviously, electricity na carry ಮಾಡುವಂತಹ component are the conductors. So through the conductors, the generated power, it is transmitted over a very long distance. And this stage athwa this portion of the electric power supply system is known as transmission system. And finally, the electrical power which has been transmitted from the generating station, it is distributed among the various consumers. Industrial consumer irbodu, residential customer irbodu, ಅಥವಾ ಬೇರೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಸಿಸ್ಟಮ್ ಇರ್ಬೋದು, ಕಮರ್ಷಿಯಲ್ ಕಸ್ಟಮರ್ ಇರ್ಬೋದು, ಇರಿಗೇಷನ್ ಪರ್ಪಸ್ ಇರ್ಬೋದು, ಹಾಸ್ಪಿಟಲ್ಸ್ ಇರ್ಬೋದು, ಎಜುಕೇಷನಲ್ ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್ಸ್ ಇರ್ಬೋದು. ಸೊ ಇವರೆಲ್ರಿಗೂ ನಾವು ಏನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡ್ತೀವಿ, ಜನರೇಟಿಂಗ್ ಸ್ಟೇಷನ್ ಇಂದ ರಿಸೀವ್ ಮಾಡಿರುವಂತಹ ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಈ ವೇರಿಯಸ್ ಕನ್ಸ್ಯೂಮರ್ಸ್ಗೆ ನಾವೇನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡ್ತೀವಿ, ಆ ಒಂದು ಸೆಕ್ಷನ್ ಆಫ್ ದಿ ಪವರ್ ಸಪ್ಲೈ ಸಿಸ್ಟಮ್ ಇಸ್ ಕಾಲ್ಡ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಸಿಸ್ಟಮ್. So this distribution system, it provides power to individual consumers. So the distribution of electric power to different consumer, it is done via a much lower voltage level compared to the transmission system. Please remember, transmission system athwa transmission of electrical energy, it happens at higher voltages, whereas the distribution happens at much lower voltages. Now the entire electric power supply system, that is starting from the generating station, the transmission, distribution and finally the consumer. So this entire electric power supply system can be represented with the help of a simple single line diagram in order to understand the electric power supply system. So as you can see here, this is a single line diagram representing the power supply system starting from the generating station. Then we have the receiving station, we have the substation, SS stands for substation, RS stands for receiving station, and we have the distribution substation, and finally the consumer. So the entire complex network of conductors from the generating station to the consumer point, it can be easily represented in the form of a single line diagram, and this is how we represent the single line. With the help of a single line diagram, the entire power supply system can be represented starting from the generating station to the consumer point. So from the generating station, the transmission can be subdivided into primary transmission and secondary transmission. Similarly, the distribution system also can be subdivided into primary distribution and secondary distribution. So we are going to see each component individually in brief. Starting from the generating station. So here generating stations are the place where electric power is produced by three-phase alternators. As I said earlier, the usual generation voltage is 11 kV. And this generated voltage is stepped up to 132 kV with the help of three-phase step-up transformers. And why we need to step up the voltage, generated voltage, to higher voltage? Because transmission of electrical energy at higher voltages, it has many advantages. So advantages, but at the same time disadvantages, characteristics of high voltage transmission ಎಲ್ಲದನ್ನು ನಾವು later sessions ನಲ್ಲಿ ಓದ್ತಾ ಇದೀವಿ. So the generated voltage, that is 11 kV, it is stepped up to 132 kV with the help of three-phase step-up transformer for the high voltage transmission. So once it is stepped up to 132 kV, and this stepping up is performed at the generating station itself. So generating station nallene ನಾವು transformer ಸಹಾಯದಿಂದ 11 kV generated voltage 11 kV na ನಾವು 132 kV ಗೆ step up ಮಾಡಿ then we transmit over a longer distance using three-phase, three-wire overhead lines. The electric power at 132 kV is transmitted from the generating station to the receiving station by the three-phase, three-wire overhead lines. Receiving stations ಎಲ್ಲಿರುತ್ತೆ? Receiving station ನಮ್ಮ ಸಿಟಿದು ಹೊರಭಾಗದಲ್ಲಿ, usually in the outskirts of the city. So generating station in the electric power at 132 kV, it is transmitted to the outskirts of our city, and the station which receives this electric power at 132 kV is called receiving station. So generating station in the receiving station tanka longer distance na electric power travel ಮಾಡಿರುತ್ತೆ. So and this travel, it is done by three-phase, three-wire overhead lines, and this forms the primary transmission. From the generating station to the receiving station, transmission of electrical energy is called primary transmission. From the receiving station, at the receiving station itself, the voltage is reduced to 33 kV with the help of step-down transformers. So high voltage transmission is preferred for longer distance. ಯಾವಾಗ generating station ಇಂದ receiving stationಗೆ distance ತುಂಬ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಅಂತ ಸಂದರ್ಭದಲ್ಲಿ high voltage transmission is preferred. But distribution, which is for shorter distance within the city, ಅದಕ್ಕೆ ನಾವು nominal voltage levels ಅನ್ನ ಇಟ್ಕೊಳ್ತೀವಿ. So at the receiving station, the voltage is reduced to 33 kV from 132 kV with the help of step down transformers. And this reduced voltage, that is at 33 kV, It is transmitted to various substations by three-phase, three-wire overhead lines. So various substations ಅಂದ್ರೆ ಈ ಸಬ್ಸ್ಟೇಷನ್ ಸಿಟಿದು ಒಳಭಾಗದಲ್ಲಿ ಅಲ್ಲಿ ಇಲ್ಲಿ ಫೇವರಬಲ್ ಪ್ಲೇಸಸ್ ನಲ್ಲಿ ನಾವು ಸೆಟಪ್ ಮಾಡಿರ್ತೀವಿ. ಸೊ ಫ್ರಮ್ ದ ರಿಸೀವಿಂಗ್ ಸ್ಟೇಷನ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಪವರ್ at 33 kV it is distributed ಅಥವಾ it is transmitted to the various substations which are located at suitable places in the city by three-phase, three-wire overhead lines, and this section forms secondary transmission. So secondary transmission, it is from the receiving station to the various substations of the city. Next is the distribution section. So again the distribution section is subdivided into primary distribution and secondary distribution. At the substation, the voltage is further reduced to 11 kV from 33 kV, obviously with the help of step down transformers. So the power which has been received from the receiving station to the substation, it is reduced from 33 kV to 11 kV for the primary distribution. Electric power at 11 kV, it is directly supplied to large consumers like factories and industries. ಕೆಲವು ಫ್ಯಾಕ್ಟರೀಸ್, ಇಂಡಸ್ಟ್ರೀಸ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎಲೆಕ್ಟ್ರೋಪ್ಲೇಟಿಂಗ್ ಪ್ರಾಸೆಸ್ ಆಗುವಂತಹ ಇಂಡಸ್ಟ್ರೀಸ್ ಇರ್ಬೋದು, ಅಥವಾ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಹೀಟಿಂಗ್ ಪರ್ಪಸ್ಗೆ ಇರ್ಬೋದು, ಇದಕ್ಕೆಲ್ಲ ನಮಗೆ ಡೈರೆಕ್ಟ್ 11 kV ಪವರ್ ಸಪ್ಲೈ ಬೇಕಾಗುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ಅವ್ರಿಗೆ 11 kV ಸಪ್ಲೈ ವಿತ್ ಡಿಫ್ರೆಂಟ್ ಫೀಡರ್ಸ್ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಅವ್ರಿಗೆ ಸಪ್ಲೈ ಮಾಡಿಬಿಡ್ತೀವಿ, ಅಂಡ್ ದಿಸ್ ಫಾರ್ಮ್ಸ್ ದಿ ಪ್ರೈಮರಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್. ಸೊ ಫ್ರಮ್ ದಿ ಸಬ್ಸ್ಟೇಷನ್ various customers where the voltage athwa electric power from 33 kV it is stepped down to 11 kV and it is distributed to various big athwa large consumers, and this forms the primary distribution. And now comes the secondary distribution. The electric power at 11 kV from the primary distribution line, it is delivered to distribution substations. ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಸಬ್ಸ್ಟೇಷನ್ಸ್ ಯೂಶಲ್ ಆಗಿ ಪೋಲ್ ಮೌಂಟೆಡ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಆಗಿರುತ್ತೆ. ನೀವು ರೋಡ್ ಸೈಡ್ ನಲ್ಲಿ ನಿಮ್ಮ ಊರುಗಳಲ್ಲಿ ರಸ್ತೆನಲ್ಲಿ ಓಡಾಡುವಾಗ ನೀವು ಕಾರ್ನರ್ಸ್ ಅಲ್ಲಿ ನೋಡೇ ಇರ್ತೀರಾ. ಪೋಲ್ ಮೌಂಟೆಡ್ ಅಂದ್ರೆ ಪೋಲ್ ಮೇಲೆ ಮೌಂಟ್ ಆಗಿರುವಂತಹ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್, ಪೋಲ್ ಮೌಂಟೆಡ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಅನ್ನ ನೀವು ನೋಡೇ ಇರ್ತೀರಾ. ದೇ ಆರ್ ದಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಸಬ್ಸ್ಟೇಷನ್ಸ್ where the electric power at 11 kV it is further stepped down to 440 volts athwa 400 volts. So from the distribution substation, that is DS, the voltage at 400 volts, it is distributed among the consumers. So three-phase, and this distribution which forms the secondary distribution, it is via three-phase four-wire system. Three-phase, more phase ಆಗಿರುತ್ತೆ, more conductors are YB, and the fourth wire is the neutral wire. ಸೊ ತ್ರೀ-ಫೇಸ್ ಸಪ್ಲೈ ಬೇಕಾದವ್ರಿಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ತ್ರೀ-ಫೇಸ್ ಸಪ್ಲೈನ ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀವಿ. ಸಿಂಗಲ್ ಫೇಸ್ ಬೇಕಾದವ್ರಿಗೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಫೇಸ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಲ್ ಮಧ್ಯೆ ಟ್ಯಾಪ್ ಮಾಡಿ ನಾವು ಸಪ್ಲೈ ಕೊಡ್ತೀವಿ, ಅಂಡ್ ದಿಸ್ ಫಾರ್ಮ್ಸ್ ದಿ ಸೆಕೆಂಡರಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್. ಸೊ ಸೆಕೆಂಡರಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ it is from the distribution substation to the consumer points. So this entire electric power supply system, which has been represented with the help of a single line diagram, it consists of the generating station, the primary transmission, secondary transmission, primary distribution, and the secondary distribution finally to the consumer points athwa consumer localities. So that's all we have today in this session. So in this session we have discussed about the electric power supply system, which forms the generating station, the transmission, distribution, and the consumer locality. So this entire network, it is called electric power supply system. So in this electric power supply system we have generating station, we have transmission lines, and the distribution system. Transmission line, it is further divided into primary transmission and secondary transmission. Similarly, the distribution system, it is subdivided into primary distribution and secondary distribution. And this transmission or distribution can happen with the help of either overhead system ಅಥವಾ overhead conductors ನಲ್ಲಿ ಆಗುತ್ತೆ ಅಥವಾ underground system which involves underground cables, that is UG cables. But most widely overhead system is adopted worldwide. So finally ಜನರೇಟಿಂಗ್ ಸ್ಟೇಷನ್ ಅಲ್ಲಿ ಏನು ಪವರ್ ಜನರೇಟ್ ಆಗ್ತದೆ ಅದು ಕನ್ಸ್ಯೂಮರ್ ಲೊಕ್ಯಾಲಿಟಿ ತನಕ ನಾವೇನು ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅದನ್ನು ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಪವರ್ ಸಪ್ಲೈ ಸಿಸ್ಟಮ್ ಅಂತ ಕರಿತೀವಿ. ಅದನ್ನು ಸಿಂಪಲ್ ಆಗಿ ಸಿಂಗಲ್ ಲೈನ್ ಡಯಾಗ್ರಾಮ್ನಲ್ಲಿ ಈ ಥರ ನಾವು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ದಟ್ಸ್ ಆಲ್ ವಿ ಹ್ಯಾವ್ ಇನ್ ದಿಸ್ ಸೆಷನ್. ಐ ಹೋಪ್ ದ ಸೆಷನ್ ವಾಸ್ ಗುಡ್ ಆ್ಯಂಡ್ ನಿಮ್ಗೆಲ್ರಿಗೂ ಅದು ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಅನ್ಕೋತೀನಿ. ಸೊ ವಿ ವಿಲ್ ಸಿ ಇನ್ ದಿ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್. ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.